Good morning. I am Professor Priya Sharma of EC Department, SIRT Sage Group, Bhopal. Today we'll discuss about the OSI model and its layers. First of all, OSI stands for Open System Interconnection, which was developed by ISO and is now considered as an architectural model for intercomputer communications. OSI model divides the whole task into 7 layers, and each layer will assign a particularly task, and each will consider its task as an individual. This is the diagram of OSI model, characteristic diagram, how these layers are divided and which are connected to the host and which are connected to the network. First of all is the physical layer, then data link, then network, then transport, session, presentation, and application. We'll discuss each one by one in the upcoming video. First of all is the physical layer. It is the lowest layer of the OSI model, whose main function is to transmit the individual bits from one node to the another node. Functions of the physical layer is line configuration. First of all, line configuration is, it defines the way how two or more devices are connected physically. The function of a physical layer basically is to establish, maintain, and deactivates the physical connection once the data conversion or the conversation is over. It specifies the mechanical, electrical, and procedural network interface specifications. This is the diagram how physical layer takes the data from the above layer, which is data link layer, and transmits it to the physical layer of the destination node. Second function is data transmission. Data transmission defines the transmission mode, whether it is simplex, half duplex, or full duplex mode between the network devices. Simplex is only sending of the information from source to destination. Half duplex is sending and receiving, but only once at a time. Either sending will be in process or the receiving is in the process. And half duplex is sending and receiving simultaneously from both the nodes. Third is the topology. It defines the topology of which topology is being used for a particular session. Last is the signals. It determines the type of signals which are used for transmitting the signals, whether it is electrical, electromagnetic, or etc. Any signal. Second, we comes to the data link layer, which is the second layer of our OSI model. Its main function is to transfer the data error-free. That means the data frames which are being generated by the physical layer or the upper layer is error-free transmission. It is a hop-to-hop connectivity, that is from one router, sender router, to the receiver router. It provides a reliable, efficient communication between two or more devices. It is mainly responsible for the unique identification of each device that resides on a local network. Coming to the functions of the data link layer, first is the framing. The data link layer adds the header and trailer to the frame. It translates the physical raw data into streams and packets, which are known as the frames. It adds header and trailers. Header contains the hardware destination and source address, which is the physical addressing. Flow control is a constant data rate is maintained on both sides of the communication so that the data doesn't get corrupted. It ensures that the transmitting station, such as a server with higher processing speed, does not exceed the receiver station with lower processing speed. Fourth is the error control. Error control is achieved by adding a calculated value of CRC. CRC is placed at the trailer, which is added to the message frame before it is sent to the physical layer. If any error occurs, then the receiver sends the acknowledgement to the transmitter of corrupted frames. Last is the access control. When two or more devices are connected to the same communication channel, then this layer is used to determine which device has a control over a link over a particular given time. So this is all about the data link layer. Third is the network layer. Network layer manages device addressing, tracks the location of devices on the network or between the devices on the network. It provides a host-to-host connectivity. Previously, the data link layer provides the hop-to-hop community, that is from sender router to the receiver router. But network layer provides connectivity from one host to the another host, that is from sender to the receiver. It determines the best path to move from source to destination based on network conditions, priority of the service, and many other factors. Routers are layer 3 devices. They are specified in this layer and used to provide the routing service within an inter-network. Now, coming to the function, this is the diagram of the network, how it takes the data from the transport layer and communicates to the data link layer. And on the receiver side, it takes from the data link layer and gives to the transport layer. It is the packet in the network layer. Coming to the functions of the network, first is the internetworking. It provides a logical connection between different devices. Second is addressing. This layer adds the source and destination address to the header of the frame. Addressing is used to identify the device on the internet. Third is the routing. It determines the best optimal path out of the multiple paths from the source to the destination. Packetizing is also done in this, in which it converts the whole data into small packets. Next, coming to the transport layer, fourth layer. The main function of the transport layer is that it converts them into smaller units known as the segments. This layer can be termed as end-to-end layer. This layer ensures that messages are transmitted in the order in which they are sent and no duplication of data is there. The main responsibility is to transfer the data completely. It receives from the upper layer and converts into segments. This layer is termed as end-to-end as it provides a point-to-point connection between source and destination to deliver the data reliably. Here in this layer, we use two protocols. First is transmission control protocol and the second is the user datagram protocol. Transmission control protocol is the TCP protocol. It is a standard protocol that allows the systems to communicate over the internet, establishes and maintains a connection between the hosts. When the data is sent over TCP connection, then the TCP protocol provides the data into smaller units known as the segments. Each segment travels over the internet using multiple routes and they arrive in different orders at the destination. The TCP reorders the packets in a correct order according to the address added in the header of the file and sends an acknowledgement to the sender that correct data has been received. If anyone is corrupted, then acknowledgement is not sent and the sender knows that the data has been corrupted. Second is the user datagram protocol. It is unreliable protocol because it does not send any acknowledgement if data is being corrupted or not corrupted. So no information is being provided from the destination side that this protocol is an unreliable protocol. Coming to the functions of the transport layer, first is the service point addressing. Computer runs, as we know, computer runs several programs simultaneously. Due to this, the transmission of the data from the source to destination, not only from one computer to another computer, but from one process to another process also. The transport layer adds the header that contains the address known as the service point address or the port address. The responsibility of the network layer is to transmit the data from one computer and the responsibility of the transport layer is to transmit the message in the correct process. Second is the segmentation and reassembly. When the transport layer receives the message from the upper layer, it divides the message into multiple segments and each segment is assigned with a sequence number that uniquely identifies each segment. When the message has arrived at the destination, then the transport layer reassembles the message based on their sequence number. Third is the connection control. Transport layer provides two services, connection-oriented service and a connectionless service. Coming to the connectionless service, it treats each segment as an individual packet and they all travel in different routes to reach the destination. A connection-oriented service makes a connection with transport layer at the destination machine before delivering the packet. In connection-oriented service, all the packets travel in a single route. Next is the flow control. The transport layer is also responsible for flow control, but it is performed end-to-end rather than across a link. Last is the error control. The error control is performed end-to-end rather than the single link. The sender transport layer ensures that the message reaches the destination without any error. Coming to the fifth layer, that is the session layer. The session layer is used to establish, use, maintain, terminate, and synchronize the interaction between communicating devices. Now, coming to the functions of the session layer, first is the dialog control. It acts as a dialog controller that creates a dialogue between two processes, or we can say that it allows the communication between two processes, which can either be half duplex or full duplex. Second is the synchronization. Session layer adds some checkpoints when transmitting the data in a sequence. If some error occurs in the middle of the transmission of data, then the transmission will take place again from the checkpoint. This process is known as synchronization of recovery. If in any of these packets, if any error occurs, then it will not start addressing it from the beginning. It will start addressing from the checkpoint where it was added, and the previously delivered data will be considered as error-free. Coming next to the presentation layer. A presentation layer is mainly concerned with the syntax and semantics of the information exchange between the two systems and is also known as the syntax layer. It acts as a data translator of a network. This layer is a port of the operating system that converts the data from one presentation format to another format. Coming to the functions of the presentation layer, first is the translation. The process in two systems exchange the information in the form of character, string, numbers, and so on. Different computers use different decoding systems, encoding methods. The presentation layer handles the interoperability between the different encoding methods. It converts the data from the sender-dependent format into a common format and changes the common format into a receiver-dependent format at the receiving end. Next is the encryption and decryption. Encryption is needed to maintain the privacy. Encryption is a process of converting the sender-transmitted information into another form and sends the resulting message over the network. And decryption is the vice versa. That is, it converts the message over the network into the form in which the receiver end is convenient. Last is the compression. Data compression is a process of compressing the data. That is, it reduces the number of bits to be transmitted. Data transmission is very important in multimedia such as text, audio, video, etc. Coming to the last layer of this OSI model is the application layer. An application layer serves as a window for the users and application processes to access network services. It handles issues such as network transparency, resource allocation, etc. This layer provides the network services to the end users. Coming to the functions of the application layer, first is FTAM. File transfer, access, and management. An application layer allows a user to access the files in a remote computer, to retrieve the files from a computer, and to manage the files in a remote compute. Second is the mail services. An application layer provides the facility for email forwarding and storage. This is how we can summarize all the 7 layers of a OSI model. First is application layer, which is from the host, that is which we are getting. This is the layer which provides the service to the user. From this application, we get the access to all the 7 layers. Presentation layer is responsible for compression mainly, encryption, description, and translation. Third, session is used to manage and terminate the sessions. That means when the communication process is on, it makes a connection, and when the communication is over, it terminates the connection. Fourth is the transport layer. It provides reliable message delivery from process to process. That means from one end to another end. Network layer, it is responsible for moving the packets from the source to destination. Then data link layer, it is used for error-free transmission of the data frames which is being created by the network layer. Last is the physical layer. It provides the physical medium, whether it is singlex, half duplex, or it is to be whether which type of signal is being used. These are, or the topology which is being used in the communication process, these are being decided by the physical layer. I hope so, students, that you get the point of the OSI model, which is as simple but theoretical, but it is not as difficult. It is easy to understand. If you correlate it with examples, it will be much easier for you to understand. Thank you. Sage Anandam.